Hello, I'm going to show you how to do elementary row operations. In this case, we're going to look at equations with three unknowns. In this case, x, y, and z. And to solve an equation with three unknowns, we need three equations to do it. Now we can do that on the graphics calculator. If we go into apps, Polysim will solve it for us. We go into simultaneous equations. We have three equations, three unknowns. Click on next. And there's our simultaneous equations. I set of 3, exactly the same as this blue here. And if we solve it, then we know the answers. 1, 2, and minus 1. Now, we're used to seeing x and y, and that's two-dimensional. So if there's x, y, and z, it's three-dimensional. So I can show you that as a three-dimensional view. And here it is here. Here's my x coming out in this direction. Here's my y going up and my z coming down. And we can see that we can rotate this graph around. Now, guess where on here is the answer x equals 1, y equals 2, z equals minus 1. Any thoughts? Well, it's just in there. It's where they cross. Just in there, where all three of them cross, all those three planes cross, that is the value where x is 1, y is 2, and z is minus 1. So now let's use that, and we'll actually get that idea, and we'll show it by elementary row operations. So here we go. Get a blank screen. Alright, so what I've done is converted it to a matrix, exactly the same. Here's my x value, so 2x, 3y, minus 1z. Notice I don't put a 0 here because there is a 1 missing in front. We just don't bother writing it, but there's a 1 missing there and a 1 missing there. So notice that's all filled in correct. Now the style to solve it is we're looking for this form here. So we need to first of all make these two 0. Okay, how are we going to do that? We leave the first line as is. We're trying to get a 0 here. That's these two. So it's always in relation to the first row, whether we're doing 3 unknowns, 4 unknowns, 5 unknowns. We always look at the first row with each of these. So that will simply be row 1 take away row 2. And I say it as I do it in my head. We've got 2 take 2 is 0. 3 take 1 is 2. Minus 1 take minus 3 is 2. 9 take 7 is 2. That's looking okay. Now let's get a 0 in the next value here. Well, to do that, we're using row 1 and this number here in row 3. To get a 0, I need to double that. So it's row 1 take away 2 lots of row 2. Let's run through it again. Row 1 take 2 of 1 is 0. That take 2 of that, that's going to become a double negative, so it's going to become 7. Minus 1 take away 2 is minus 3. And 9 take away double that is going to become 9 plus 8 is 17. Alright, what do we do now? Well, we could simplify this middle line to see how we've got 2y plus 2z equals 2. So we could actually, if we wanted to, rewrite that line as 2, 3, minus 1, 9, 0, 1, 1, 1, and 0, 7, minus 3, 17. I've simply taken row 2 and divided it by 2, or times it by a half. Alright, so this time we're going to write it out again, exactly the same. First row now is okay, we want that solid, like over here. There's our 0 that we want, so that's okay for the second one. And now we need to get a 0 here. So we need to get a 0 in this space here. So how are we going to do that? Well, it's going to be in relation to row 2 and row 3. So if I times row 2 by 7 and take them away, I should get 0. Let's try that. So we've already got a 0 here, and if we do 7 lots of nothing take away nothing, it's still nothing. 7 lots of 1 take away 7 is 0. 7 lots of 1 take away 3 is, 7 lots of 1 take away negative 3 becomes a positive, so that's 10. And 7 lots of 1 take away 17 is minus 10. Fantastic. Breathe a sigh of relief. Now let's take those. This bottom line now is really saying that 10z, because this, don't forget, this is the x, y, and z columns, so 10z equals, does this line mean equals minus 10. And if that's true, then z equals minus 1. Phewie, that's the answer we wanted. Now we're going to take the second line up. Let's change the colour. This is saying that y and z equals 1. So 1y plus z equals 1. I already know z is minus 1, so y take 1 equals 1, so y must equal 2. Fantastic, that's what it was. And now let's take the opening line, either off here, same value here, or let's take it over here. So we'll take it off of this. We know that we have 2x plus 3 lots of y is 2, plus 6, minus 1 lot of z, and z is minus 1, so that's going to be plus 1, equals 9. 2x plus 7 equals 9. X equals 2x equals 2, x equals 1, which, yes, is the answer. So there I have showed elementary row operations and linked it to what it means on a three-dimensional object. I hope you found that useful.